Hello friends, welcome to my channel Physics with Rakshi. In the present video, we will embark on journey of expanding universe according to book Theory of Everything authored by Stefan Hawking. In two previous videos, I explained introduction to the book and origin of universe according to book, where we show history of our universe right from Greek era to general theory of relativity. In the present video, we will see some concepts regarding expansion of our universe like Hubble's law, Big Bang, Penrose theorem, discovery of microwave background radiation, etc. Let us start. In 1924, Edwin Hubble demonstrated that our galaxy was not only galaxy, there were many other with vast tract of empty space. We know that our universe doesn't have boundary, and in this universe there are many galaxies like our Milky Way galaxy. By taking various observations, Hubble found that various galaxies are moving away from each other, and by this observation, he told that our universe is expanding. It means our universe is not static. So Hubble used indirect method to prove it. Any star's brightness depends upon two parameters, luminosity and their distance from us. By determining these two parameters, we can understand stars of Milky Way, and by this indirect method, we can also predict these two parameters of stars of other galaxies so that we can compare our stars with other stars of other galaxies. So certain stars which are having same luminosity and are in our galaxy can help us distance to galaxy assuming same luminosity, as I told. So by this way, he worked out the distances to 9 different galaxies. We know that in our universe, there are approximately 10 raised to 11 galaxies, and each galaxy, there are 10 raised to 11 stars. It means our universe has approximately 10 raised to 22 stars. So there are approximately 10 raised to 11 galaxies, with each has 10 raised to 11 stars. Milky Way is approximately 1 lakh light years across, which is slowly rotating, and every star, including our sun with overall solar system, is rotating around it, and it has spiral arms. We know that Andromeda galaxy is our neighboring galaxy, which is moving away from our galaxy. So only one characteristic feature about majority of stars that we can measure is color of their light. Here, atomic and molecular physics comes into picture by observing spectrum of stars of different galaxies. We can understand some concept regarding expansion. Like by observing this spectrum, we can say that these galaxies, spectral lines of spectrum of these galaxies are shifted towards red color. It means that these galaxies are moving away from each other according to Doppler effect in cosmology. So different stars have different spectrum, but relative brightness of different colors is always exactly same when light is emitted by object and it is glowing hot. Glowing hot means spectral lines of these spectrums are shifting towards red color. So we can measure temperature of stars from their spectrum, and by spectrum one can determine presence of elements in stars atmosphere just by taking spectral lines of these spectrums and interpreting the spectral lines. We can determine how many elements are there in the atmosphere of stars. In 1920s, astronomers began to take observation regarding spectrum of stars of galaxies They found same characteristic set of missing colors as for stars in our galaxies. It means universe repeats same structure, same configuration as our galaxy has. So it means this spectral lines shifted towards red end of spectrum with same relative amount. So galaxies are moving away from each other according to Doppler effect of cosmology. In 1920, Hubble also discovered one of the important concepts, that is size of galaxies, which is red shifted, was not random here but directly proportional to galaxies distance from us. We are measuring distance from Earth, and which is proportional to size of galaxies which are red shifted, and it is not random. Further, the galaxy was, the faster it was moving away from each other. It means our universe is expanding, and the idea that our universe was static according to Newton, Einstein was completely wrong. Hubble proved that thing. So universe is expanding and distance between galaxies is continuously growing. Slow expansion may be stopped by gravity. If all galaxies are moving away from each other slowly, matter content of universe can halt expansion of universe. But this expansion rate is if bigger, gravity cannot stop expansion of universe, and our universe will expand forever. So expansion at critical rate never be stopped by gravity. In this diagram, I have shown a picture, cyclic picture of our universe, in which first of all Big Bang was occurred. Thereafter our universe will expand. Thereafter at certain point, because of gravity, it will again contract, it will again recollapse, and in the other direction it will again expand. After certain time it will again contract. So this is the cyclic picture of universe according to some model of cosmology like loop quantum cosmology, which is known as Big Bang model. In 1950, Albert Einstein discovered general theory of relativity, and he delivered field equation which explains evolution of our cosmos in time. He also introduced cosmological constant in his field equation to prove static universe. But thereafter, sometimes discovery of Hubble's principle, Einstein understood that cosmological constant was biggest blunder of his life. Though, according to present quantum field theory and cosmology model, cosmological constant is one of the important cosmological physical quantity to understand our cosmos. Thereafter, Friedman came up with some cosmological models and assumptions that our universe is homogeneous and isotropic. In simple word, universe looks identical in whichever direction we look. This was the first assumption. Second assumption is that it's true if we are observing universe from anywhere else. Right now, and all physicists are observing universe from Earth as we are living on Earth. If we observe our universe from other galaxy, other place, or other planet, universe will look same according to these two assumptions. It was given by Friedman in 1922. But here we have to consider large scale physics, as I'm talking about galaxy scale, not star scales, not planet scale. We are seeing galaxy scale and large scale physics. In 1965, Penzias and Wilson, who designed a very sensitive microwave detector for communicating with orbiting satellites, they received extra noise from all direction around Earth. They took many observations to determine from the source of this noise, and they came to conclusion that its source was outside of atmosphere of Earth and beyond solar system and galaxy. It means whatever radiation that they were receiving came from outer source behind cosmos and beyond, behind our galaxy, Milky Way galaxy, beyond our galaxy. It means they were receiving signals from all directions, which is known as microwave background radiation. And by these observations, they proved first hypothesis or assumption of Friedman model that our universe looks same or identical from all directions. It means, as I told, Penzias and Wilson confirmed Friedman's assumptions. Thereafter, people and Dick in USA were also looking for this radiation at the same time when Penzias and Wilson found it in physics. It happens sometimes that same discovery was discovered by different physicists, but credit goes to those who discovered it first. So thereafter, in 1978, Penzias and Wilson received a Nobel Prize for this discovery of microwave background radiation or detection of microwave, which comes from all direction out of our galaxy. So till this point, physicists could understand that universe is expanding, and according to this assumption, our universe looks same. It means our universe is homogeneous as well as isotropic. Thereafter, some physicists came with more ideas. According to this physicist, Big Bang was the initial condition of our universe. Let us see. In 1935, Robertson and Walker discovered models of expanding universe based on this idea of Hubble and Friedman model. There are many conditions, as I told. In almost all conditions, almost all models, Big Bang was the first choice of all cosmologists. Other choices are recollapse, Big Crunch, Big Freeze, etc. In recollapse, what happens after certain amount of expansion, gravity will come into picture and universe will again recollapse to that point. These all models are determined by rate of expansion, average and critical density. If our universe has more density or more dense, it means it has more matter content. Expansion will be halted after sometimes by gravity, and because of gravity, universe will contract. If universe doesn't have enough density, it means our universe will expand forever. Another thing is, by studying all these things, one can understand that there is something more beyond matter content, that is dark matter and dark energy, which is responsible for this expansion rate. As we know, only 4% matter content of our universe, 25% matter content is dark matter, and 70% is dark energy that we cannot understand completely till today. So what is Big Bang? Initially, one explosion was occurred. At that time, line metric of our universe, that is ds square, is equal to dt square d minus dx square minus dy square minus dz square was 0, as there was no interval. And at that time, universe density was infinite and curvature of universe was also infinite. So universe was completely singular. That cannot be explained in classical physics. Physicists had infinity anomaly that occurs in equation. Somehow we have to remove infinity anomalies to make equation more tangible. Thereafter, physicists found many other celestial objects in our universe, right from solar system to stars, galaxies, cluster of galaxy, cosmic web, and up to universe. Thereafter, during World War, some physicists like Bondi, Gold, Fritz found radar by observing radio waves, which was one of the important discovery and which is very helpful and which has many application in defense and space technology also, in normal life also. By observing radio waves, we can have many other observation of cosmos and we can have many other discoveries. So, u- universe was started by that giant explosion that we call Big Bang. At that time, universe was hot and denser and singular. It means its R is equal to 0. Thereafter, Hawking explained some other very fascinating ideas in his book in this chapter that in 1965, Penrose explained space-time singularity considering black hole by considering stellar collapse. We know that when any sun runs out of its fuel, because of its arm gravity, it will be collapsed to singular point that we call stellar black hole. And at that time, Stephen Hawking was pursuing his PhD and looking for any fascinating idea. He took this idea for his study and discovered some more important concept regarding cosmos. So Penrose theorem, using this concept of Penrose and Hawking theorem, we can have understanding of black hole singularity. So Penrose and Hawking, by collaboration, understood singularity, and Hawking, by considering time reversal of collapse of star or stellar collapse, could understand collapsing star which ends to singularity, which is also known as Penrose-Hawking theorem. So by conclusion, I can say that our universe is expanding by considering Hubble's idea, Friedman's equation, etc. And our universe acceptable condition is, initial condition is Big Bang, where one giant explosion was occurred and universe was hot and denser at that time and also singular. This singularity could be understood using Einstein's general theory of relativity, but not completely. You have to consider quantum physics. By unifying quantum physics with general theory of relativity, that is quantum theory of gravity, one can understand and remove singularity from these models. Thanks for listening and watching. If you have any question regarding this chapter, that is expanding universe, you can ask in the comment section. In the next video, we will see black holes, which is one of the fascinating objects of physics. Thank you.